So this demonstration is to hopefully go over a few things briefly to remind you of a couple things from pre-algebra type math that hopefully you either remember or hopefully this will help you remember. So this one here wants you to complete this table, and you have a fraction, decimal, and percent. So the fraction of 7/12, in order to get the decimal, really all you would have to do is do 7 divided by 12, and you can use a calculator for that for the time being, or whatever the case may be. Sometimes it's better just to leave it as fraction because this has a repeating decimal, which makes people inclined to round it. And sometimes a more accurate calculation is needed, so keeping the fraction is oftentimes desired in those kind of cases. But you can see what the decimal is. The percentage, since this is 58.3 hundredths, basically the percentage, all you really have to do is just multiply your decimal by 100, which basically is moving the decimal point 2 spaces to the right, and you'd get 58.3 repeating percent, or 58 and 1/3 percent. We often don't use mixed numbers a whole lot in algebra because that causes confusion between the addition that you actually have in a mixed number, and oftentimes students want to treat it as a multiplication because you get used to having things that are next to each other seen as multiplication. So we often don't use mixed numbers a whole lot in algebra type courses. For here, you're given the decimal. Now this is 0.025 thousandths, so you have 25 thousandths because it ends up in the third position. So you would do 25 over 1,000. And with fractions, you always want to simplify into lowest terms. Both of these are divisible by 25, so this would simplify into 1 over 40. And again, to turn this decimal into a percentage, it's always better to go to decimal to percentage. It's just a moving of a decimal point. This would be 2.5%. Now, with the percent being given first, it's not too hard to convert it back to a decimal. You would just take the decimal point, which is right here, and you move it 2 spaces to the left. You'd have to put a 0 in to compensate for that another space, and you'd have 0.02. This would be read as 2 hundredths, so you would have 2 over 100. And again, with all fractions, we always simplify the lowest terms. Both of these are divisible by 2, so this would be a 1 over 50 in lowest terms. 1 over 200, already in lowest terms, so you would carry through the division. And when you do that, you get 0.005. This is tenths, hundredths, thousandths, so you have 5 thousandths here if you wanted to read it that way. But again, to make it as a percentage, this would move 2 spaces to the right, and you would end up with 0.5%. So for the decimal of 0.35 or 35 hundredths, you would convert that to a fraction by, since it's 35 hundredths, it's 35 over 100. And since both of these are divisible by 5, you would divide both by 5 to simplify it and get 7/20ths as your simplified fraction. Again, to make this into a percentage, you would move this 2 spaces to the right and get 35%. And for the last 1.8%, to convert this to a decimal, this would move 2 spaces to the left, so you would have 0.008 as your decimal, which is tenths, hundredths, thousandths, so that's 8 thousandths. So when you start with the fraction, it's 8 over 1,000. Both of these are divisible by 8, so when you simplify it, you would get 1 over 125. Now, when you're asked to do problems where there's percentages of things involved, sometimes it gets difficult to know, are you finding the percentage of something, or are you finding the percentage of the original total, or are you finding the total that you were originally taking a percentage of? And so we always want to get the idea that there's a general format you want to try to fit the problem into, which basically is percentage of total equals value. Percentage, we'll call it P here. Of is always translated into a multiplication, T a total, and you get a value of your percentage. So you got to try to figure out, if in any problem, which of these you're being given. You can set up into this format and then solve appropriately. So for here, a survey reported that 76 people, or 16%. So you're told that 76 people is this 16%. So this is the value of the percentage. You were asked how many people were surveyed. You're looking for the original total. Now keep in mind that this percentage should always be expressed in decimal form. So here, you know that this is the value you got after you took your percentage. You're looking for what the original total was. So when you set this up, you're going to have 0.16 times t equals this 76. And then it just becomes to solving a simple algebraic question. You're not going to see a whole lot in this course about solving algebraic equations because that is a skill that you're expected to more or less have at this point and know the procedures of doing so. So dividing both sides by 0.16, you get that t equals 475. So originally there was 475 people surveyed. Here, there's 366 people who attended a street fair. 35% of them bought more than $100 worth of tickets. Approximately how many people attending the street fair bought more than $100 worth of tickets? So here, you know how this is the total number of people who attended. This is a percentage or a group from that percentage. So this is your total. This is the percentage. You're looking for the value. So again, using this general format to set it up, you're going to have 0.35 times 366 equals the value. And this is just, calculating, carrying through the multiplication. You get 128.1. So you would round to about either 128, 129 people bought more than $100 worth of tickets. And you see if you actually do 128 over 366 and 129 over 366, they're both about equal to 35%. So one's just a little bit below it, one's a little bit above it. So for C, out of 45 students in the calculus class, 38 studied for the quiz. They are being given today. What percentage studied for the quiz? So here, you're told that the total's 45. You know that 38 is the value. That's the subset of that. The percentage is what you're looking for. So again, setting this up, you're going to have P times 45 equaling 38. You divide both sides by 45. You get 0.84444 repeating. Now this is the percentage as a decimal. So moving that 2 spaces to the right, you get about 84.4 repeating percent. Lastly, you're going to see some problems that will involve histograms or tables that will have either an actual frequency and a relative frequency. The frequency is the actual part of the total that you have, whereas the relative frequency is a percentage. Make sure you always know which one you're dealing with in all the cases, because sometimes a percentage is sometimes better to report than the actual frequency, especially if you have very wide variety of values, and sometimes the other way around. But anyway, if you were asked to complete a table like this, you're told that the age group of 1 to 20 had 38% of the frequency. So you would do 38% of this 137, or 0.38 times 137, and you would get approximately equal to 52. Now with that 52 known, and you know what the grand total is, if you add these up, subtract that from the 137, you see that there should be about 22 people left in this group. That lets you do the relative frequencies for these three, because this is going to be 35 over 137, 28 over 137, and 22 over 137 respectively. You calculate out their percentages in decimal form, then you convert them to percentages. The relative frequencies, if you have all your categories accounted for, should total about 100%. This could vary a little bit. Sometimes you might get like a 99.9 or a 100.1 depending on rounding. Try to avoid that as much as you can, but sometimes it's not avoidable. But generally you want the total of your relative frequencies to equal 100% when all is said and done. But this is the demo. Hopefully that gives you some reminders of things dealing with fractions, decimals, and percentages. And now feel free to start looking into some of the examples.